This is E. Lakshmi Lydia from Vignan Institute of Information Technology, working as Associate Professor. And I welcome you all to the experimental manifestation of Big Data Analytics through Hadoop Advanced MapReduce on behalf of IUCEE. I would like to give my thanks for giving me an opportunity to the IUCEE to speak in the webinar. As well as I would like to give my heartfelt thanks to my college institution, that is Vignan Institute of Information Technology, my chairman, my principal ma'am, head of the department, and all my faculties for providing an opportunity to speak like this. It's a great pleasure to me. I welcome you all. Let's start the session now. So, people who have attended the previous seminar, the previous webinars, for them it will be more useful because they might have got the understanding regarding the big data analytics and what is MapReduce and how to perform the analysis by using the MapReduce. We have seen through the previous webinar, right? So in today's session, we're going to cover these concepts such as overview of MapReduce. Just maybe 1 minute of time we will take for that. Today, maximum we will focus on the practical session and a little bit advanced concept of MapReduce. So we will discuss about the overview of MapReduce and what is the weather data, how can you perform the analysis on the weather data, how can you perform the analysis on the healthcare, because people who are doing research, for them it will be very advantage that how can the analysis can be performed Hadoop, and we are going to perform some experimenting on weather by taking the weather data sets, and we will also perform some experimenting on healthcare data sets also. And later on, we are going to see some advanced concepts of MapReduce such as combiners, partitioners, counters, joins, distributed cache, sequence files. These are all the some advanced concepts of MapReduce. We can say that these are some features of MapReduce. The programming will be as usual only, but we are going to implement some new features in that. So if time permits, we are going to see the experimenting with data distributed cache and with the sequence files also, because the remaining things are little bit easy and simple and nothing there to implement much more. But these two concepts are very important for implementing practically. Right, let us just have the overview of what is MapReduce is. So already in the previous webinar we have discussed about the MapReduce. The same thing I'm repeating here as an overview point of thing. So a MapReduce is nothing but a heart of the Hadoop, and it is a programming model for which is designed for processing large volumes of data, in which process in a parallel manner. It is going to process by dividing the work into set of independent tasks. The programming model that is called as the MapReduce programming model will work. The framework possesses feature of data locality. The meaning of data locality already we have seen in the previous webinar. So the data locality means movement of algorithm to the data instead of data to the algorithm. Just imagine that we have got plenty of data. We have got plenty of data here, and what we are going to do is we are going to write the MapReduce algorithm or program, and I'm going to put into the data, and on this data the analysis is going to be performed. Whereas in the older mechanism, what we used to do is we used to move the data, the reverse mechanism we used to do. We used to move the data wherever the algorithm is there, and then we used to perform the analysis, right? So that thing was happening with the previous things. So that is called about data locality. And when the processing is done on the data, algorithm is moved across the data nodes rather than the data to the algorithm. So this architecture is so constructed because moving computation is cheaper. Moving computation is cheaper than moving the data. That is the benefit of using the Hadoop. So this is a simple overview of MapReduce, and MapReduce is a heart of the Hadoop framework. Why it is called as heart of Hadoop framework? Because in Hadoop, in the Hadoop, when you see about the Hadoop ecosystem, we have got number of components like MapReduce, Hive, Pig, HBase, and all those things. So whenever we are performing our job with help of Hadoop ecosystem, eco components, what is going to happen is every command, if you are performing the analysis by using Pig, it is going to be converted into MR coding only. If you are performing the analysis by using Hive, it is going to be converted into MR coding only. So that is why we call it as a heart of the Hadoop ecosystem. Right. So let us go into the deeper session now. Today's session. Let us take the weather data and let us perform the analysis. Right. So and we will take about we will take the what you say that the healthcare data sets also, and then we are going to perform the analysis. So I would like to start my webinar with the experimental analysis. So I would like to take to my Cloudera, right? Now, let us see uh, we are performing experimenting on weather data set. So we are having these data sets. What is my data set? I'm having my data sets. So already I have said you that whenever before performing the analysis, all data must be kept in the HDFS. That's the thing we have discussed in the previous webinar. We can say that this is the continuation of last webinar. What are the webinar we have discussed in the last webinar? There's a continuation of that. So yeah. So whenever we are working with the HDFS, whenever we want to perform the analysis, the first and the foremost job is we need to put the data into the HDFS, right? So that is the first step we need to do, right? So step one is keeping the data into the HDFS. Then step two is running the jar file. So jar file means what here? Again, we need to create the jar file. That is a big process. So once the jar file is created, then the whole job is over. So these are the two steps we need to perform. So let us see first what is the data set we have. My data set now. So I go to the name node status, browse file system, and I have kept my data set in the user Cloudera. So I have got my data set called as temperature. So this is my temperature data set where we are having complete data. So from the year 1900, I'm having the data sets here. So in the 1900, I have collected some data. What I have collected here? Some temperature, 39, 14, 5, 11, 20, 20, 22, 15, 41, 42, likewise. So in this 1900, which year, or sorry, which is the maximum temperature in that 1900, I want to find out. Similarly, 1901 also, which is the maximum temperature we have, that I want to find out. Similarly, so we have data set up to the year 2013. So we have collected data set up to 2013. So 2013, what is the maximum temperature? 2012, what is the maximum temperature? 2011, what is the maximum temperature? So like that we want to find out. So these are the big data set we have considered. So what is our task? Our task is to perform the analysis. What is the analysis we are going to perform? So in which year, which year has got the maximum temperature? That is the thing we need to perform, right? So this is a simple analysis. This is not a big analysis. So for this purpose, what we have to do is the first and the foremost thing, as I said you that the step one job is we need to keep the data set into the HDFS. That is the first step. Second step is we need to run the jar file to perform the analysis. To perform the analysis, we need to run the jar file. And step 3 is we need to store the result. Right? So these are the steps, 3 steps we need to perform. But these 3 steps are simple, but creating the jar file itself is a difficult job, right? For this purpose, what we have to do now, the first thing is that first of all we need to create a Java file, and then we need to execute them, we need to compile them, and then we need to create the jar file. We need to create the CVF file or jar file, right? That's called a compressed file. Once the jar file is over, the whole program is over, the whole thing, the whole task is over. Now you no need to write this jar file every day. Every day you no need to perform that job. Just once, whenever we have a new task, we are going to create a jar file for the new task, and we are going to keep them aside. And whenever we want to perform that particular task, we will take our weapon and we'll throw for analysis, and our Hadoop is going to do that job, right? So these are the 3 steps we need to perform now. So before performing these 3 steps, I would like to show the program, how the program goes on, right? So you can see the program. This is a simple program. There's nothing difficulty is there here. Just normally we have simple program here. So we have the normal Java package here, Java IO and util packages we are having, and these are simple. Our org.apache package is there. This is the most important package, I can tell you that, because in this package only we are using all the whatever the configuration settings and all we are doing, all those jobs we are doing here. So the program, I have made a comment stating that what the kind of program is doing this. This is the temperature program where we are finding the maximum temperature corresponding to that year. That means I should get the output basing on the year. That means how the output should come like this. That means in 2010, 32 is the maximum temperature. In 2011, 34 is the maximum temperature, and 2012 my maximum temperature is 34 again. Just I'm considering it, I'm imagining. Again 2013, I'm considering the temperature as 39. 2014, something like this, right? This is the output like this. I'm expecting. This is my analysis I want to perform, right? So for this purpose, we have written a small Java program where what we are doing in this is just as usual. The previous class we have discussed that how the MapReduce works. Map is a function or a method, and reduce the method. So the map method reads every data. What it reads every data? For example, it reads this line. The map method, it reads this line. After reading this line, what it will do? It will break this data into chunks. It will break this data into chunks. So 2001 is one data and 29 is one data. Again the loop goes on. 2001, again 19. Again loop goes on. Likewise the things goes on. So it takes one line and breaks into number of chunks. That is the duty of the map. So what the reduction will do? Reduction will simply perform the just normal thing that is called as the aggregation job. It is going to perform. So we are having the normal thing. We are having a map method. The map method is extending the my super class called as MapReduce base class, and it is implementing the interface called as mapper, right? And I am writing my map method. This is my map method, and in the map method, first step, as I said you that we are taking the line. First of all, the first is that is the first and the foremost duty, taking the line, and then what we are doing now, breaking the line into tokens. That is the thing we are doing. String tokenizer is breaking the record according to the delimiter. That is, what is the delimiter here? I am having white space. So this is my white space, right? So between this data and to this data, so what is the delimiter I am using? Space, white space. If you are using comma, you have to put comma here, right? So the loop is going to be repeated like that, and we are reading the data here, and we are performing the temperature also, and all the output will be collected, and then the output will be stored here. So in the map method, we have not performed any kind of analysis. What we have done, we have simply taken the data, because what is the basic principle of map method? The basic principle of map method is nothing but reading the data. Whatever the input data is there, that input data is going to be readed, and it is going to be take the one line and breaks into number of chunks. So that is the frequency of the job it is going to be performed, right? So what the reduction is doing now, here I am writing a small logic. There's nothing big logic here, right? So we are having a reduce here class. See, this is the difference here. This is a class and this is a method here. So my calculator is my class, my method is my small letter here, right? So reduce here. So I'm repeating here, while values dot has next. If max temp less than temperature, I'm just putting on loop continuously. If it is having less than temperature, value it, right? And finally collect the output now, right? So that's what the job is performing. So in this program we have not written the major logic part. The whole thing is that the step-by-step operation of the Hadoop only we are specifying, not more than that, right? And the program will start from the main actually, apart from the map and reduce. I'm setting the configuration and setting the output key class and setting the output key value class, because what is the basic principle of MapReduce? The map method takes the entire data and then takes one by one line and then broken into number of chunks. Then it makes into us as a key value pair. That means what? This is called the key value pair. Key value like that it's going to take. Every individual thing is going to be broken into key value pair. So that's what we are specifying here, key value pair, right? And we are setting the map output class, set map output key class and output value class, mapper class, reducer class, and then set input format we are performing and set output format we are performing, and then ultimately arcs of 0 and arcs of 1. What is this arcs of 0 and arcs of 1? Did you remember or not, in the previous webinar when we are discussing whatever the input file we want to perform the analysis, that will become my arcs of 0. And what is my arcs of 1? Arcs of 1 is nothing but simply my the output file where the result I want to store. That is my arcs of 1. And all these things we are running the job here by saying the method called run job, and in the here I'm passing the conf. So conf has got all these settings regarding the key value, mapper, reducer, all things are there here. So this is what the program goes on. Now how to perform the analysis is that you have to see now. To perform the analysis, the first and the foremost thing is we should have this data set. Unless we don't have the data set, we cannot. Just imagine that the client has given this data set, right? Or yeah. Now what I am performing, just I will open my terminal window. So this is my terminal window, right? Now the first and the foremost thing is we need to put the data into the HDFS. So for that purpose, what I am doing is just this is my present working directory. Root home Cloudera is my present working directory. I am trying to find out my temperature data set is there or not. Yes, it is there. So now I am going to put this data inside the HDFS. So for that purpose, we are going to use the command Hadoop fs -put, and then I'm using Hadoop fs -put, and I'm using my data set. Oh, I made a mistake. Right. So what is the meaning of this here? So fs is my file system, put is my command. Similarly, we are having get command also. So this is my source, root home Cloudera. Where do you want to put? I want to put in the root user Cloudera, right? This is my source, and this is my destination. So since already it is there, I am getting this command message stating that already exists. So you can go to this is my web interface. So I have already shown you in the previous webinar how to go to the web interface. So this is my web interface. So go to this web interface and name node status, go to browse file system, and then I'm saying user Cloudera. So this is my temperature data set, right? So this data set I have kept in the HDFS. So once we have kept in the data set, the job is over. Every day we no need to keep the data set. Once we have kept in the data set in the HDFS, we can perform the analysis, whatever the kind of analysis we want to perform. We want to perform the minimum temperature, or we want to get the maximum temperature. Whatever thing we want, we can perform the analysis. Whenever there will be changes in the data set, then we need to put one more new data set into the HDFS. Or what we have to do, we need to remove the old data set from the HDFS, and we need to put the new data set into the HDFS. That is a mechanism we need to put. Don't try to overload the HDFS data sets more, because if you are working on master slave architecture, to reduce the unnecessary data, it is when you feel that the data is not at all useful for us, better to remove it. Just simply remove it. That's more than enough. There is no need to take much pressure on that. Like old data, new data, everything, no need to keep it. Just remove it. Nothing else. Right? And here, one more important thing is people get confused here. What is that is, to remove the data set, they go simply to the web interface. They go to the web interface, user Cloudera, and they try to remove from here. No, that is not. No, this is like this. We are not going to delete. So you cannot delete like this, because it's a HDFS. You cannot delete like that. Then how can you delete? You can delete from here, by giving the command only. We need to delete here, right? So just we need to give the command here, Hadoop. We need to say Hadoop minus RMR remove command, and the whatever the file name is there, that command we can remove it. So I'm not removing it because we need to perform the analysis right now. So first step is over. That is my first step, right? What's the first step? My keeping the file into the HDFS. Now already we know that we have written the Java file. My temperature data set is there. For writing the Java file, you can use this notepad file for writing the Java program, what are the Java program we are having. And since my Java program is already there, so I'm going to run it now. So my program name is temp, I believe that. Yeah, so we need to run it. But before running the program, we need to set the class path. Why we need to set the class path? Because when we are writing the program, we have imported so many packages. These are all the org.apache packages. And these org.apache packages are available in the jar file. What is my jar file here? This is my jar file. What is my jar file? Yeah, this is my jar file. Right. So this is my jar file. And how do you got this jar file? We got this jar file. Just I have gone to come see. That is the beauty of Cloudera. Cloudera, we are not going to face all such problems. So from where we got, just I have already shown you in the previous webinar, but again I am showing you. So go to file system, user lib, and we have Hadoop here. Go to Hadoop 0.20, and we have lib, we have This is the jar file. Just simply copy it and paste it in the Cloudera, because this is my working place. I'm here only, I'm working here. Just paste it here. That's it. Finish. The job is over. So this is the jar file, right? So we need to set the path of the jar file. So just for our understanding, yeah, I'm just putting the path, because since already, yeah. So I'm setting the path and then compiling the program. So I'm going to compile the program, say JavaC temp.java. My program name is temp. Just I have already shown you. My program name is temp, right? Right. My program name is, yeah, temp, class temp, right? So my program name is temp, JavaC temp.java, right? So we got it, the things here. Warnings we can omit it, not an issue, that is. So when you compile, after that you can see here we got these 3 class files. What are the 3 class files we got? One is temp.class file, temp map class, and temp reduce class. I have written only one program actually, which I have shown you, but in return we got mapper and reducer, and we have the normal temp class. Now what is the next job here? We need to compress this file 1, 2 and 3, and then we need to create the jar file like this, right? So already jar file is there. So I'm going to create the jar file once again for your understanding purpose. So how to create a jar file? I'm saying here jar cvf temp.jar temp star class. So what is temp star class here? Nothing but simply whatever the name will start from temp. So with that I want to compress them, right? So we can see here, yes, these are the 3 files added. If any one of the file is missing, means what? Something goes wrong. So our program will not work. So this is the thing. That is the reason we need to count how many class files has been manifested, how many class files has been added. So one is temp.class file, map.class file, reduce.class file. So my compression has done perfectly, well and good, right? So the same temp.jar file has been created now. So all the steps are over. First step is what? The keeping the data into the HDFS. I have created the jar file. That's it. So this, once this jar file is created, you can keep them as long as there is no change in the data sets, or as long as data sets may change, may not change, as long as the logic has not changed. Like as long as your requirement has not changed, you can keep the data set. Like if you, when your requirement is changed, then you require to perform your new logic again, and then you need to keep the jar file, and whenever we want, we are going to run it. So now we are going to run the jar file now. So how I'm going to run the jar file is, I'm going to say like this now. So what I'm saying here, oh, I'm going to say like this. I'm not going to run now because I need to change something here. So what I'm saying now here, Hadoop is my command. Jar, I'm running the jar file. Where is your jar file? My jar file is present in this path, root home Cloudera. My jar file name is temp.jar. And what is your program name? Temp. What is your data set? Temperature. This is my output file. This is my output file. So if this output file is already there, I'm going to get an error, and you're going to say, without the output directory will not store the data, right? So for that purpose, we need to check whether the data, whether the directory is there or not. I think it is there, so I will change it to temp or Vignan temp. I'm going to say there is a temperature of Vignan, I can tell you that. So, and then when I run the program, so once again, short and sweet, Hadoop is my command, jar. I'm running the jar file. My jar file is located at this path. Temp is my program name. My data set is temperature, and I'm performing the analysis on this only. That's what this is called as args of 0, and this is my args of 1. So when you're writing the program, At last, I have shown you this. What is that? Arcs of 0 and arcs of 1. What is arcs of 0? The input path, that is called the file which you want to perform the analysis. What is arcs of 1? Arcs of 1 is nothing but your the output file, whichever the output file we want to run, store that output file. So I'm running the program now. Now our map and reduce starts now. So this is the ID has been given for our job. Map is 0%, reduce is 0%. The job of map and reduce not yet started. Yes, map 100% over. In the meanwhile, you can go to this part and you can check also job tracker status, and you can check here, right? There are a number of, see here, temperature is going on here. This is the status, and you can check here. Map is 100%, reduce is 100%, and the complete execution has done. The graph it has shown, right? That is the benefit here. The job tracker is showing how much job has done, right? And then, yeah, complete job is over. So totally, the reducer has done 1199 reduction, and how many slots it has done? 120907. So like this, the analysis has, this is the analysis report. This is the important report. What kind of job you have done, what kind of data you have done, and what the MapReduce has done. So how much time the MapReduce has taken. So all this information we are going to get, right? So for this purpose, so output has done successfully. So if I go and check Vignan temp now, so I can find out now that the result. So I'll go to this my web interface. I can go to my name node status, browse file system. So by default in this path, the output will be stored. So I'll go to the Vignan temp. So by default, a file will be created with a name called part-0000, right? So if I click here, you can see here, these are the temperature, right? So in 1996, the biggest, these are the highest temperature. In 92, 48, in 1909, 49. Likewise, the temperature has been got, right? So maximum we can find out 49 is the biggest, the highest temperature. So this, like this, we have performed the analysis, right? So like this, the temperature can be performed, can perform the analysis. So this is one set of analysis we have performed, and now the next experimental, I'm going to the next thing, which is a little bit tough here. The previous webinar and this webinar, we have seen a small working with a small data set simply, but now in this experiment, little bit tough job we are going to see, that is called as, yeah, solving problem with MapReduce by working on the healthcare data sets. So people who are performing work on healthcare data sets, like people who are performing mining on gene analytics or disease patterning, something like that. For them, it's a small idea actually. It's not a big information. It's a small idea I'm giving with this. So just what we have to do is now, what is my purpose of showing this is nothing but I'm performing de-identification here. If data sets are shown, then the job will be performed very quickly, right? So this is my data set, my healthcare data set. Yeah, this is my data set. So in this data set, this is my number, name, date of birth. These are all the information, right? These are all the different informations of different patients, different diseases. We can see here: fever, diabetics, PCOS, and blood pressure, malaria, swine flu. Again, something like these are all the diseases. We can see this, right? Number of different types of diseases we can say that, right? Yeah, these are all the different types of diseases. Now what is our job is, what kind of analysis we are going to perform in this is, for blood pressure, cold, and for malaria fever, it will not be a big issue. But people who suffer from or who are infected with HIV or some sort of dangerous diseases, according to the norms, their name should not be come out. Their name should not be disclosed. So it should be kept secret. But if all the names and such informations are kept quiet, how can you perform the analysis? How the government will be knowing that how many people were infected, what kind of precautions has to be taken? So all these things has to be performed now. For this purpose, what is our duty is, we cannot give that patient's information, neither the date of birth of that, neither the email ID. Now what we have to do now, we have to de-identify all these things. We need to encrypt all these data now, and then what we are doing after encrypting, we are going to decrypt, and we are going to find out how many patients were infected with HIV, how many patients were infected with swine flu, like this. So that is a job we are going to perform. So here I am not counting, my analysis is not counting how many were infected with HIV and all. My biggest job, because that job we have already done with help of word count program and all, the counting job. So that is the simplest job actually, frankly speaking. But now what is the difficult job I am doing here? The difficult job is I am performing the de-identification here. That means what? I need to encrypt all these things here, because the patient information should not be disclosed. According to the norm, we need to implement that. So for that purpose, I need to encrypt it. So here I am making use of base 64 algorithm also in this job, right? So whatever these data sets are there, I'm going to perform the de-identification job now. So let us see this here. Let us see this here. I'm putting the data. I'm putting the data into the HDFS, taking DB dump into CSV format, and then ingest into the HDFS. And after that, this data, what is going to do? I'm going to, anyhow it is there in the HDFS. And now I'm going to do what now? We are going to read by using the MapReduce. We are going to de-identify the columns based on the configuration. What we are going to do? We are going to de-identify the columns based on the configurations. So we are going to perform reduction here, and then what we are going to do? We are going to perform the de-identification. That means what? We are going to encrypt it. That's it. So that no patient information is disclosed to anybody. The patient name is not disclosed. The patient email ID or the patient phone number, all are encrypted here. So that is a job we are going to perform now, right? So experimentally, how to do that job, we are going to see now. After that, we are going to go with the advanced MapReduce. Yeah, a small program. Just I'm going to give you a simple, a brief explanation. That's all, not more than that. So we have used some packages here. We have used some packages, and then these are all my org.apache package. And in this program, to perform the encryption job, to perform the de-identification of job, I have made use of base 64 algorithm. This is a big project actually. An important project, and this can be extended at any level. It can be made as a very big project, and it can be made as it is a real-time project which is happening in various healthcare systems also. So we are making use of base 64 algorithm, and then we are making just taken as a small variable public static integer encrypt call. So this is my encryption mechanism, and then taken as a byte key array, and some value I have given, and dot get bytes to get the bytes here, and I'm writing a map method here. So simple job again. What the mapping is done here? Simple job as usual. It is going to take the map method entire data. The map method will take the entire data and it will read every line. After reading the every line is going to broken into number of chunks. Again from chunks, it is going to be as a key. It's going to make as a key value pair, and then the and then given to the reduce. So reducer is going to perform the some sort of aggregation and all thing. But if required only, we are going to give to the reducer. Otherwise, no, because in the previous webinar also we have discussed that every program must, meaning it is not mandated that every program must and should have the reducer. Why? Because we may not perform any some sort of aggregation. I want the map should perform only taking the line and then breaking into chunks, and then I'm going to implement some other principle, right? So that's the job of the map. So the map has done all these things, right? It is adding the call, and then here, yeah, the most important thing is, yeah, as I said, you just know every program may not have the reduce. Similarly, my program also does not have reduce. Why? Because as per logic, there is no reduction job is done. What we are doing, we are performing the decryption. We are performing the de-identification. That's all. When you want to count, when you want to extend this project for counting how many patients were infected with swine flu, the count you want, then you can go for reduction compulsory. Then you have to go for reduce method. And then for example, again, if you count again, like state wise, I want to count how many patients, how many were infected with swine flu. Country wise, I want to count how many were infected with swine flu. What is the death rate of the swine flu. These are all the things. So for that purpose, then we need to go for reduce method. So how many reduce method we are going to write? Reduce method for one reduce method for the world level, and then from in the country level we are going to go for the state level, region level, like that we are going to subdivide it, and we are going to get the analysis. That is a perfect analysis for the diseases things, right? Yeah. Now the program is going to start from the main. So the main job is as usual only here. Here, yeah, this is my arcs of 0 and arcs of 1. This is my input file analysis. This is my output file where the output is going to be stored. So here, the output will come only in the form of de-identification. So we are not going to get any proper output here. We are going to get the de-identification output only we are going to get here. So this is a function I have written where we are performing the encryption. That's all. This is a function I have given where the encryption I have performed. That's all. This is the logic I have written to perform the encryption job, right? Yeah. Now, just simply built-in algorithm only I have used. I have not used any special kind of logic here. Just simply I have made use of base 64 algorithm. With your effort and all, you can use any other algorithms to provide a more level of encryption standard and all. So this can be extended any level, right? Now, yeah, because with this thing, if the time permits, in the next webinar, uh, we are going to discuss on privacy on big data, how the privacy can be implemented on the big data. Because here, the problem here you can see is big data is a collection of structured, unstructured, semi-structured, all data is there. Complete data is exposed now. But now the question comes is, where is the privacy? What kind of mechanism we can implement to provide the privacy? That is the next important thing we are going to discuss, right? But now we are, as a analyticals, we are just performing the analysis only, right? Let us perform the experimental job on this. I'm going back to my Cloudera. right? Now I have got two data sets. I have got two data sets. One is data set 1, data set 2. So in this case, people can ask me, we have to perform individual analysis. No, no, not required. You put in one directory of HDFS. In HDFS itself, you create one directory, and then you put all these datasets in one directory and directly give the directory name to perform the analysis, right? So that like that we can perform the analysis. But now I'm going to perform the analysis on only one dataset by taking off either dataset 1 or dataset 2. So as usual, the first step is keeping the data set into the HDFS. So that's the first job. So I'm not typing, just I'm pasting it. So Hadoop fs minus put. This is my source. This is my destination. So where is my destination? My destination is root user Cloudera. Where is my source? Root home Cloudera. So once you keep this, it is saying that target already exists. Just now I have shown you. Here. Already it is there. Go to browse file system, user, Cloudera, and it is there. The whole data set is there now. So we are going to perform the analysis now. For this purpose, the program should be there now. So already we have seen the program. So my program is de-identify data. So I'm going to compile it for your understanding purpose. Already the program is there. So I'm going to compile it just for understanding purpose. And then right now it is giving error also. What is the error it is saying? Base 64 algorithm I have used, that package is not exported because I have exported only the Hadoop jar file only I have exported. So that package is missing now. For this purpose, I have to export that package also now, right? So intentionally I have shown you to show the usage, what kind of errors we are going to face in this, right? So for this purpose, I'm going to export now. So what I'm going to export, see, you can do like this. First step is you can export the jar file. Second is you can export the commons code 1.4.jar file where we have base 64 algorithm, commons code EC. Where do you find this common code again? This commons code also we can find in the same place. That's what the beauty of Cloudera. Go to my computer and you can see here file system. You don't need to search for all these jar files. Where is the jar file and all? You don't need to run towards browsing and all. Just simply you can, everything is under the one roof only. So go to user, USR, lib. Go to Hadoop jar. Go to lib. We can find, yeah, we got the common code, right? Just simply copy it and paste it in the Cloudera. That's it. Job is over, right? So that is the thing. So I have already exported this package, so I'm not going to export that. So this is a package. See, if two things, if you want to export both at once, then we can run. You can do like this also. Export. This is one file. Put colon and one more file. I don't want to export it during runtime only. I want to perform. You can do like this also. Java C, de-identify.java, and then export like this also. So any of the step you can follow. So I will follow the simple step because already it is. I have imported the Hadoop jar file. So I'm going to import it, export it, and then I'm going to run the program now. So I'm not going to get the error. Right? The job is over. Right? Warnings can be considered. Right? So compilation is over. Just check it now. The class files, how many class files we got, right? How many class files we got? 1, 2, 3 and 4. 4 class files we have got it now. What we are going to do now, we need to compress it, all these things, right? That is called as creating the jar file. So I'm creating the jar file, jar CVF. Just I'm using right. So what is my jar file name? D.jar. That's it. But something goes wrong because only two classes has been added. This and this has not been added. So this jar file will not work perfectly. So this is the thing we need to understand. So I have to run the uh, jar file once again. Right. So two class map and reduce, three things. LSD identity. Yeah, I'm very sorry because here we are going to get only two. These are separate files because we don't have reduce. So since we don't have reduce, we're going to have map and data class only. That's all. We don't have reduce. So three files we are not going to get, only two. So it is right, absolutely. So there is nothing wrong here because we are not written reduce here. So I'm going to run the jar file now. Just simply I'm going to say here like this. Right. So Hadoop jar, my jar file name is d.jar. This is my Java program name. This is my this is my data set, and this is my output file. So I'll say as Vignan D output, right? So Vignan D output is a file. So when you run the program, what is going to happen is all data which I have shown you will be de-identified. Because the data is more and I'm working on pseudo mode. In my lab only I have my master and slave, so it's taking little bit of time. If you work on master slave architecture, it will be very quick. So let us go to the name node status. What is my data? You have performed the analysis on healthcare. Where is your healthcare? This is my data set, right? So let us find people who are having diabetics, right? So what is the output we got? Cloudera Vignan D output is directory, and this is the output file by default. Yeah, this is the thing we got it. What is this? This is completely a decrypted here, right? This is a de-identified data here. Sorry, de-identified data here, right? So this is one patient information. So people, how can you identify now who are having diabetes? What is the last column? We need to check it now. Let us go back again. What is the last column of healthcare data set? Yeah, last but one is the disease, right? Again we can go Vignan Cloudera, right? So here, yes. So this is the de-identified data for the diabetics. Now, if we cannot find out anything, and with wait also we cannot perform anything. But with the help of name or email ID, we can find out. So which people, which patients does not want, their data should not be disclosed, right? So this is the job we have performed with the help of base 64 algorithm. For the extension of this, by using the reduce method, we can find out the things called as uh, how many people were infected with swine flu, how many people were infected with HIV. So that is the next extension of this project. So this is what about the de-identification. The time is running, so there's too much of practical experiments. So, so let us now go with the theoretical part. Yeah, these are all some of the advanced concepts of MR, MapReduce, that is called as the combiners and partitioners. These are the features of MapReduce, which we call as the advanced MapReduce also. So what are combiners are? Combiners are nothing but mappers produce large amounts of intermediate data. That we know. What is a map? Map takes the data and it produces large amount of intermediate data again, and that data will be given to the reducer. So that must be passed to the reducer. This can result in lot of network traffic. So it is often possible to specify a combiner. What is a combiner here? To avoid the network traffic, what we can do, we can make use of combiners, which is going to act as a mini reducer. What the reducer is doing, performing the aggregation. The combiner will also is going to act as a mini reducer here. It runs locally, where it runs inside the single mapper's output, and output from the combiner is sent to the reducer. So what is the benefit of using the combiners feature? The benefit of using the combiners feature is the job of the reducer will be reduced. Why? Because the whole job, half of the job has been done by the mapper only, because we have implemented the combiner, which is acting as a mini reducer. So combiners and reducers code are often identical. Technically, this is possible if the operational performed is cumulative and associative. Then we can see the importance of this combiners, right? So that is called as combiners and reducers. You can see this is a normal thing we have seen, right? How the map is going to perform. The quick brown fox, the fox ate the mouse, how now the brown now, like that's something we have written the input file, we have performed the mapping. This is the old thing we have done. But here what I have done here, something called as a combiner I have added here. So immediately what happened now, some sort of reduction has done here, which you have given to the reducer here. So the job of the reducer has been reduced. So it improves the fast. Partitioners are what? Partitioners determine which reducer is responsible for particular key. The partitioner divides up the key space and controls which reducer each intermediate key and its associated values goes to. Often the default behavior is fine. Default is called as a hash partitioner. So that is about the combiners and partitioner, how it works. So short and sweet, in a one single word, to improve the performance, to reduce the network traffic, we can implement the combiner, which is going to act as a mini reducer. This is one topic of the advanced MapReduce, or we can consider a feature of the MapReduce. So how it goes on, the diagrammatical representation we are seeing here. We have a map, we have a partitioners, and how the partitioners is taking the to the reducer. So that the image we are seeing here, pictorial representation. The next feature is called as a counters in the advanced MapReduce. Did you observe or not, whenever we are running the MapReduce, there is a counters is there. This is the counters. What is the counter? How many times the counting has done, how many times the operation has done, that's called the counters. So the counters is the inbuilt operation present in the MapReduce. If you want to perform the counters explicitly by your own, then you can make use of counters, right? So counters are useful channel for gathering statistics about the job. For quality control or for application level statistics, counters can be implemented whenever they want, right? So that is about the counters. So a small thing which I am just implemented through the program. How the counters can be implemented by using the enumerations, that is called the enum. We can implement the counters. But one more important thing is counters are implicit job of the MapReduce. If you want to implement it explicitly, then we can make use of counters. Because the time is short, already 4:35, so that is the reason I'm not going with the experimental job. The next important thing is joins. The most important feature is joins. So what is these joins are? We have a map side join and reduce side join. What is map side joins and reduce side joins are nothing but here. I want to show you something important thing here now. I cannot show this practically because the time is running. Right now, as I said you, every data has to be kept into the HDFS. But what happens now, just imagine that I have got some data here and some data, this is one data set, this is another data set. And I want to combine, I want to join the data present in this data set also as well as in this data set also. In that case, what I'm going to use the joins concept. So in MapReduce, we have the joins concept. If we are implementing the joins at map side, we call as a map side join. If we are implementing the joins in the reduce, we call as a reduce side join. So what are joins? Joins are nothing but I want to join the data of this data set to this data set, then I'm going to use the joins, right? So in MapReduce, we perform the joining with the help of the concept called as joins. If you see the Hive is a one more eco component of Hadoop. There we have already joins concept, as like in the Oracle structured query language we have joins, simple join, equi join, non-equi join, something like that. The same manner here also we are having joins. Here we are writing a big program in the MapReduce. In Hive we are not going to do that job. Simple query we are going to do, the job is over. That means what? According to the analysis wise, we are spending this much of time for MapReduce and we are spending this much of time which you are performing analysis with the help of Hive. So that is a time differentiation we can find out here. So if join is performed at the map side, we call as a map side join, and if join is performed at the reduce, we call as a reduce side join, right? So that's what I said here. If the joins are performed at the mapper, we call as a map side join, and if the joins are performed at the reducer, we call as a reduce side joins, right? Actually thought of showing that experiment, but the time is running, so that is the reason I couldn't able to run. I'm just showing the things. Yeah, one more important thing of MapReduce, advanced MapReduce is distributed cache. What is distributed cache is nothing but here. What is distributed cache is nothing but here. See, sometimes we don't want to keep everything on the HDFS. The data which is required to perform the analysis, I'm going to put into the HDFS. And some data I'm not going to put into the HDFS. I'm going to keep in the cache memory. So in that case, what is going to happen? Just simply half data or the important data is in the HDFS and some data is in the, again it has got stuck, and some data is present in the cache memory. So for that purpose, I'm going to make use of distributed cache, right? So what is a distributed cache? So what is the distributed cache here? Distributed cache is nothing but rather than serializing site data into job configuration every time, it is preferable to distribute data sets using Hadoop distributed cache mechanism, which provides a service for copying files to the task nodes in time for the task to use them. That means at the time of performing the task, you can keep the data into the cache and use them when they run. To save network bandwidth, what is the benefit of distributed cache? To save the network bandwidth, files are normally copied to any particular node once per job, right? And then the last important thing is sequence files. The sequence file is also a very important job of the Hadoop MapReduce. As I have said you that the map is taking the input data. The map is taking the input data. It is taking the input data. It is reading one by one line and breaking into chunks. But if the data consists of images, this is one image, one more image, one more image, then in this case, images cannot be broken. Images cannot be broken. If it is a data, some CSV files or some TXT file, that can be broken. But images cannot be broken. Neither the audio files can be broken, neither the video files can be broken. For that case, what I am going to do is, how can I perform the job is, I am going to make use of sequence file. What is a sequence file? A sequence file is a flat file consisting of binary key value pair. Internally, the temporary outputs of maps are stored using sequence file, where it is splittable so that they work well with the MapReduce, and they are going to work in a faster manner. So what is going to happen? For every image or for every audio file, a sequence file, a binary key value pair. What is a sequence file? A binary key value pair is going to be generated, and from that binary key value pair, we are going to perform the analysis. So performing analysis on audio, video files, that is called as unstructured data, is little bit difficult job. Why? Because we need to generate the binary key value pair, and from that binary key value pair, we need to perform the analysis. What analysis we are going to perform? For example, we are giving some 10 or 15 images. We want to find out the images which has got the good clarity with good pixels. So in that case, we need to run this sequence files, right? So we can perform the sequence file either by the raw record, either by the block. So in any of the way we can follow, either by the record manner or by the block manner, we can run the sequence file, right? This is the record manner, the block compression and record compression. This is your block compression, how the works on number of records, compressed key lengths, compressed keys, all these things. Internally, how it happens, right? We'll stop the things now. If you have any questions, you can pass into the webinar. So short and sweet, today we have covered almost all the important things. We have worked on the weather data set. We have worked on the healthcare data set, where we have performed the de-identification by using the base 64 algorithm. We have seen some advanced MapReduce features like counters and combiners and partitioners, distributed cache, and we have seen the sequence file, which is very, very important. Thank you so much. If you have any queries, you can pass.
Hello.
Hello.
Is it possible to analyze large data in Windows 8.1?
Yes, it is. Hadoop is not concerned to OS. You can make use of any operating system. Hortonworks and all is compatible with the Microsoft. We can make use of Hortonworks and all, and you can perform the analysis.
What size of data set is considered?
What size? I didn't get the question.
What size of data set is considered?
Generally, any size is acceptable, but whenever we give the data set, by default, every data sets are going to be broken into 64 MB by default. If the data sets, if you are working under master slave architecture, in that case, the administrator is going to increase the block size from 64 MB to something else. Similarly, every block is going to be replicated in 3 manners. That's called 3 blocks. But if you are working on terabytes, petabytes, and all, in that case, three replicas is not sufficient, because if all 3 nodes are not working, means the data is gone. For that purpose, you need to increase the replica size and you need to increase the block size also.
How is Hadoop analysis different from R programming analysis?
Yeah, good question you have asked. Our programming analysis is almost all related to this, but little bit thing is some sort of business analytical things we are going to see. That's a different thing. There are similarities are there, but I can say you in a single word that more advanced things we can perform there in a different fashion compared to this. Like apart from this business R and all, we can perform on Informatica and all. If the chance and time permits for me, uh, the next webinars we will conduct on the advanced things like business R is one, VR that is called as, and Informatica also we can provide. And the upcoming tool compared to MapReduce, Spark is also one more thing. If the chance and the time permits, we will speak on those technologies also.
Is a Hadoop DFS required for all big data applications?
Actually, the question is the simple thing is you can run this as long as you're running simple program. You don't require any DFS architecture. That's called as Hadoop works on single mode, pseudo mode, and master slave architecture. That's called the master slave architecture. So working on single node, there is no master, there is no slave at all, and there is no question of replication. There is no, you are not using the power of Hadoop, frankly speaking. So you don't have any DFS, nothing, or any HDFS, and no, nothing is there. If you want to work like that, as long as you're working on simple data set, we are not performing any big kind of analysis, then we can work it as usual. Otherwise, we need to make use of DFS, and HDFS implementation is mandatory. Yes, sir.
Is there any alternative to HDFS?
Alternative to HDFS. There is no alternation to HDFS. The only thing is that we need to create our own file system, like how the what you say this Google file system is there. With our own efficiency, we can go ahead. There is nothing impossible. Uh, yes, sir. Good question, of course.
Thank you, madam. That was all the questions. The participant also thanking
Okay,
you.
sir. Right.
Thank you, ma'am.
Thank you, sir. Thank you so much. Right. Close the session.